Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 2, Section 2, Chapter 5, Topic 5. Exploring Manufacturing and Material Variations in Design of Experiments, DOE Analysis. Introduction. Design of experiments, DOE, is a statistical methodology widely used in manufacturing and engineering to optimize processes, improve product quality, and understand the impact of various factors on performance outcomes. One crucial aspect of DOE analysis is capturing manufacturing and material variations from design values. This overview delves into the significance of accounting for these variations in DOE analysis, exploring how they can affect process outcomes, and how DOE techniques can help mitigate their impact. Understanding manufacturing and material variations. Manufacturing and material variations refer to deviations or uncertainties in process parameters, material properties, or environmental conditions that occur during the manufacturing process. These variations can arise from various sources, including equipment tolerances, material properties, operator skill levels, environmental factors, and process variability. Key types of manufacturing and material variations. 1. Equipment variability. Manufacturing equipment, such as CNC machines, injection molding tools, or semiconductor fabrication equipment, can exhibit inherent variability in performance due to factors such as calibration errors, wear and tear, or mechanical tolerances. These variations can affect process outcomes and product quality. 2. Material properties. Raw materials used in manufacturing processes, such as metals, polymers, or electronic substrates, can exhibit variations in properties such as composition, density, mechanical strength, or electrical conductivity. Material variations can arise from factors such as batch-to-batch variability, supplier differences, or environmental conditions. 3. Process parameters. Manufacturing processes involve numerous parameters, such as temperature, pressure, speed, or feed rates, that can vary from their nominal values due to factors such as equipment settings, operator adjustments, or environmental fluctuations. Process parameter variations can affect product quality, yield, and performance. 4. Environmental factors. Environmental conditions, such as temperature, humidity, or ambient vibration, can influence manufacturing processes and material properties. Variations in environmental conditions can impact process stability, repeatability, and reliability. Significance of capturing variations in DOE analysis. Capturing manufacturing and material variations in DOE analysis is essential for several reasons. 1. Process optimization. Understanding the impact of manufacturing and material variations on process outcomes allows engineers to optimize process parameters and control factors to achieve desired performance targets. DOE analysis helps identify critical factors and their interactions, enabling process optimization and performance improvement. 2. Quality control. By quantifying the effects of manufacturing and material variations on product quality, DOE analysis helps establish robust quality control measures and tolerance specifications. It allows manufacturers to set acceptable limits for process parameters and material properties to ensure consistent product quality and reliability. 3. Risk management. Manufacturing and material variations can introduce risks such as process failures, product defects, or performance deviations. DOE analysis helps assess the likelihood and severity of these risks, allowing manufacturers to implement mitigation strategies and contingency plans to minimize their impact on operations. 4. Cost reduction. By identifying sources of variability and their impact on process outcomes, DOE analysis enables manufacturers to reduce waste, scrap, and rework, leading to cost savings. It helps optimize resource utilization, improve yield, and streamline manufacturing processes to enhance efficiency and competitiveness. Thanks for watching. Please like, share, and subscribe.